So this is a bit of a review from last time. We talked about having components which make life easier in discussing electronic circuits, and we talked about these three components: a DC voltage supply or a battery, a DC current supply, and a resistor. Each of the three components is characterized by their IV characteristic. The voltage of a DC voltage supply is some value V, which does not depend on the current, so the voltage as a function of current is just V. Usually that V, I'll often use capital V to represent a fixed voltage. Sometimes we write it in, here it's listed as 5 volts. But I will often use capital V as well for a variable current. Remember, the IV characteristic says that the voltage as a function of the current is the voltage as a function of the current is just a straight line. It does not depend on the current. Likewise, for the DC current supply, the current doesn't depend on the voltage. So if I draw a similar set of axes, but have the x-axis be voltage and the y-axis be current, then the current does not depend on the voltage again. However, we'll leave it at that. For the resistor, as I've drawn it, I have the voltage as a function of the current. As I've written down the equation here, I have the voltage as a function of the current, and in that case, I want to put the current here and the voltage there, and then I will draw a straight line through the origin, and it's exactly the slope of this line that is the resistance R. I know that because I've written down the voltage output, and then it's R times I gives the slope. I could have flipped it over and drawn the current as a function of the voltage. I still get a straight line, but the slope of that line is now 1 over R, which we sometimes will label G and call the conductance. So we're now going to solve our first circuit, and I'm going to solve this circuit here. It's as simple as you can imagine: a 5 volt DC voltage supply and a 1 kilo ohm resistor. Now we will always consider the components to be connected at things called nodes, and so there are 2 nodes in this circuit, one at the bottom and one at the top. In each case, the battery or the DC voltage supply is connected to the resistor, and solving the circuit in this case means finding the voltage between the 2 nodes, which is very simple in this case, and finding the current that flows around the circuit. In this case, I'm going to think the current flows like this. I'm going to find I. It's I that is the non-trivial part in this particular circuit, because clearly the voltage difference between the 2 nodes that I've drawn is exactly 5 volts. So to find the current, we just have to look at the resistor here, and we can write down its IV characteristic, which will allow us to solve the problem. So what's its IV characteristic? The voltage is the current times the resistance, and we know what the voltage is. It's 5 volts, and therefore if we want to find the current I, we just have to take 5 volts and divide by 1 kilo ohm, in which case we get 5 milliamps. A couple things to note. When I said the voltage is this voltage is the current times the resistor. I was a little hasty. I should have drawn in what exactly I meant by that. I mean the voltage here measured this way, plus to minus. And remember the convention that we established last time. The current should always flow into the plus side. So here I've labeled the resistor as having a voltage drop in this direction. That V, this V means this V. And that's the voltage I want to, well, that's the voltage I know to start with to be 5 volts because it's the same as this voltage here. And then I want to find the current, and remember the current goes through the resistor. Again, I always want to make sure it goes into the plus and comes out at the minus sign. Now let me solve a similar circuit where I've replaced the DC voltage supply with a current supply. It all works the same way. Let me label to begin with this time. I know there's a current I flowing around in this direction, and I want to find the voltage across the resistor, plus to minus like this. I know that there's 2 nodes there, and my voltage V that I've just written down is actually the voltage difference between those 2 nodes. So again, the key is the IV characteristic for the resistor. I know that the voltage is the resistance times the current. In this case, I know the current is 10 milliamps, and I know the resistance is 1 kilo ohm, so I just plug those things in, and I have 1k ohm times 10 milliamps. And in this case, it's nice because the factor of 1,000 implicit in the kilo ohms exactly matches the factor of 1/1000th in the milliamps. Let me make this milliamps clearer here. And then I can just multiply the 1 and the 10, and I get that the voltage is going to be 10 volts. And so I've solved this system too.